Hey, I want to introduce you to some of the new graph features in Tracebook. So let's say that maybe you have a show tomorrow where you will be using a Cara 2 and an SB15M. These are just two speakers I sort of chose at random, but I wanted to start with something easy, two speakers from the same manufacturer that are more likely to work together. As far as I know, maybe they're even from the same generation. But all I did was went over here to Tracebook and I went to the search page, and then I started typing in L acoustics, and then that brought up a bunch of these results. And I can command click and open up as many of these as I want to. Now, once I have two of them open, then I can actually put them on the same graph together. So initially, when you look at these graph settings, it might not seem super relevant. Why would you want to invert the polarity of one speaker and look at that? So that might be a little bit helpful, but where this really comes in handy is if you would like to make sure that these speakers are somehow compatible. So one way I can do that is by coming over here to this subwoofers measurement. I can click copy measurement. That just copies into the clipboard an identifier for Tracebook, and then I'll place that here. It's a unique ID, and I'll click add to plot. And then that'll show up in this orange color here. So I might start by taking a look at the magnitudes here and saying, oh, okay, if it ends up like this on my show tomorrow, then where's the acoustic crossover going to be? Well, it's going to be in this area, right? So then I might look down here and say, okay, well, in that area, can I find some alignment between these two? And now we can't create presets necessarily here because these two speakers were probably measured at two different distances and with two different delay locator settings. And I can confirm that by looking down here. I see 2.65 meters, 12.29 milliseconds. And here, yeah, different. So slightly different. So unless those numbers are exactly the same, I can't really make preset values out of this. But I can use it to just quickly judge some, level of compatibility on these phase graphs. So what can I do here to start playing around with these and see if they're compatible? Well, I can start playing around with the delay and the polarity, and I can just start clicking buttons here. But instead of fishing around, I'm going to look at doing a calculation and just see if I can get these phase traces to at least lay on top of each other at a single point. So let's look at 125 hertz here and see how far apart they are there. So this yellow guy at 125 hertz is at 71 degrees, and this guy at 125 hertz is at 173. So they're about 100 degrees apart in this direction. But I already know just by looking at these that I need them to wrap around in the other direction. What do I mean by that? It's 120 degrees in this direction here, but really I know that I'm going to need it to wrap around this way and come back out the top, right? So instead of 100, what's the other way around going to be? Well, it's going to be 360 minus 100, which would be 260. So then I can calculate 260 divided by an entire cycle at 125 hertz. And then for milliseconds, so I can try 5.78 milliseconds, 5.78. And this, obviously, I went in the wrong direction because the phase trace is way too steep here now in blue. So I can easily just put a negative symbol here. And now we're aligned at 125 hertz. So I might want to zoom in here a little bit. And we see I'm aligned at 125 hertz, but I'm not really aligned through the rest of the crossover region there. So now I can start playing around with modifying this result with whole cycles and half cycles. Well, what's a whole cycle 125 hertz? Well, it's 8 milliseconds because 1,000 divided by 125 is 8. So half of that would be 4. So which way do I need to go here? Well, I'm manipulating this blue guy here, and I can see that I need this blue guy to, oh, it undid the zoom there. So I need this blue guy to tilt up more this way, right? So I need to keep adding negative delay basically to keep it tilting up. So let's try adding 4 milliseconds here. So I'll change this from 5 to 9. And then I'm gonna also need a polarity inversion, right? Because I'm doing half a cycle. And now we see a complementary alignment here. And so now I can have some degree of confidence that when I get in the field tomorrow, I'll be able to create a nice alignment, something that looks like this. Now that was pretty easy, I feel like, because these two speakers are designed to work together. But what if it was something a little bit more difficult? What if it was a different speaker from a different manufacturer? So here I just went to the search page in Tracebook and I just typed in subwoofer to have it bring up a bunch of its subwoofers in its database. And I just sort of picked one of them at random that looked like it would have good data for this video. So again, I can copy measurement. And now what's interesting over here is that I could keep adding to this. So I can add this to the plot. And so now I have 3 things, and now this graph is getting pretty busy, right? So I think what I'm going to do is just remove this acoustics one from there for now, and I'll reset all these values and kind of start over again. And one thing that I'm noticing with these new features is that we do have coherence blanking, but that only is going to affect the blue guy there. It does not affect the one I just added, that orange guy. So we probably want to update that so that the coherence blanking affects everything that's visible on the graph, not just the primary one. Okay, so what do we need to do here to sort of judge this compatibility? Well, it looks like I'm going to need to go in the other direction this time, right? Because I've got this blue guy, but I need him to probably come down this direction to meet that orange guy. And so when I'm looking at a graph like this, I'm just looking for some easy answers, some easy milestones. So for example, I see that this yellow guy is almost down to negative 180. So I can do an easy, quick calculation and just see, okay, so at 70 hertz, where is this blue guy then? And he's at negative 49. So then I could just calculate 49 divided by a full cycle, divided by 70 hertz, and then to get milliseconds. So I'll put in 1.94. And that didn't work. Why is that? Well, yes, this blue guy was at 94. I'm sorry, 49, wasn't it? Let's see. Yeah, 47, 49, 49, but they're actually not 49 degrees apart. So I got confused there. So they're not 49 degrees apart. So I need to subtract 49 from 180 to get the difference, because I'm interested in the offset there at 70 hertz, not just that one value. So now I should have a correct result here, 5.19. Let's just go to 5.2, 5.2. There we go. Now they're lined up at 70 hertz, but it looks like I could do a little bit better, right? They're not aligned through the entire crossover region. So I need this blue guy to bend up a little bit now this way. Maybe I actually went in the wrong direction. But now that I have one frequency matching here, I can easily try whole cycles and half cycles to see if I can find a better result. So what is half a cycle at 70 hertz? Well, I can just do a shortcut and divide 500 by 70. I get 7.14. And now I need to subtract that from my original answer to get negative 1.94. So negative 1.94. And I need a polarity inversion because I did half a cycle. Looks like I put in 5.94. And there we go. So that's looking a little bit better, and I could, probably play around with it even more. And I would want to take a look at, where this ultimately will end up, because it looks like the subwoofer is really high right now. So where exactly is that crossover region, and then how close can I get her? But you can see here I'm already, within 60 degrees all the way up until about 141 hertz. So that's probably going to be fine. And I'm doing just examples with mains and subs here because that is a common thing we need to know about, but also because it's easier to see on the graph here. So I would love for you guys to try this out and let me know what you think. Try and see if you can break it. Let me know where you can find bugs. Let me know what other features you think might be helpful to make these graphs really helpful here in Tracebook. All right, thanks.